In this video we'll be looking at the skills needed to solve three-term equations. In the main, the idea is all centered around the concept of inverse processes. By inverse process, if you're going to add a number to something, the inverse process to that would be to subtract. If you're going to subtract a number from something, the inverse process would be to add, and so on. Same with multiplication and division. The two are inverse processes of each other. So if you multiply by 3, the opposite process would be to divide by 3. This is the first three-term equation that we're going to look at solving. On the left hand side you've got 2x plus 4 equals 10. The idea behind this is to find the value of x. So the very first thing we need to do is to get rid of the plus 4 that's there. Now at this stage what you need to think is inverse processes. What is the opposite of adding 4? The opposite of adding 4 is obviously to subtract 4. So we begin by subtracting 4 from both sides. If we subtract 4 from the first side, we just end up with 2x, and then we have 10 minus 4. The next line down will give us 2x is equal to 6, because of course 10 minus 4 is 6. Now that we have two lots of x equals 6, hopefully if we do the inverse process of timesing by 2, which is divide by 2, we should see that x is equal to 3. This solves the equation as we found the value of x there. We haven't found the value of 2x or 3x, we found the value of just x by itself, okay, which is the key to solving three-term equations. Okay, we'll look at another example now. This one, slightly different numbers but the same process again. This time we want to make sure that we do the inverse process of adding 6, which obviously is to subtract 6. So we take 5x, take 6 away from that side, just leaves us with just 5x, is equal to 21, take away 6. Once we've done this, of course, we have 5x is equal to 15. Okay, and then naturally the inverse process of multiplying by 5 is to divide by 5, giving us x is equal to 3 as our final solution. Okay, we'll look at another example, slightly different this one. Hopefully what you can see, the main difference here is that instead of adding 6, we're taking away 6 this time. Now in this situation you need to think about inverse processes again. What's the inverse of subtracting 6? That would be to add 6 to both sides. So we take our 5x, okay, we add 6 to that side, we just end up with 5x equals 19, add 6. So 5x is equal to 25, and hopefully you can see straight away that 5 times 5 is 25, and so x is 5, gives us the solution. Moving on to another example. 4x minus 8 is 20. The inverse process of subtracting 8 is equals to add 8, so we have 4x is equal to 20, add 8. 4x is equal to 28, and then 4 times 7 of course is 28, so x must be 7. At this stage you should be in a position now to try the self-marked worksheets, sheets 1 and sheet 2.